A.P. Turley, when we hear of the great scientific discoveries yet to be made, chemistry rarely features highly. Has this dog had its day? Well, I never thought of chemistry as being a dog. Although my favourite molecule is nitrosoethane, and if you've seen some of my presentations, it is a dog, bit of a dog, that molecule, and it wags its tail. I think the dog community would be a bit irritated by that sort of contention, but nevertheless, I think it's fair to say that chemistry is a mature subject. I mean, the great breakthroughs were that we understand what a bond is. Okay, I mean, Feynman said that the most important thing to be passed on to other generations, if all other knowledge has been lost, was that there were little things called atoms, and at long distances they attracted, and at short distance they repelled, and went to nuclear reaction, went to separated atoms, and so that's the potential curve, and that's chemistry. So it's downhill a bit from there, because chemistry is that we are all made of these things. And then Dalton put together the conclusion that atoms existed, and then basically chemistry started. Then there were exciting breakthroughs of benzene and things of this nature, structure. And then I would say that DNA is a molecule as well, and so that's chemistry. The discovery of DNA could quite easily have been a chemistry Nobel Prize. Indeed, hemoglobin, which is also a big biological molecule, was a chemistry prize of Max Perutz. And so we move on, and we realize that chemistry is a sort of subject, a rather overarching subject, which now has major impact in material science, in condensed matter physics, and in molecular biology. And I think one problem is that chemistry is losing out there, because it is chemistry, but the cutting-edge chemistry now is being subsumed into other areas. And I felt for quite a while now that the traditional structure of universities is counterproductive, and that instead of basically chemistry department, physics departments, and engineering departments, there should be departments in which basically nanotechnology, which is chemistry of the 21st century, is being carried out. And so I think there's a valid point here, and I think this presents a problem in education, because I think people who run universities and in government don't really appreciate that they see the cutting edge advances in condensed matter physics and this, that and the other, in nanotechnology or molecular biology or in materials engineering, and don't realize that it's chemistry. And I think that will present a problem in the future, because people going into these areas will have very poor chemical understanding, and chemistry is a very rather unusual subject, I think, in that it's very complex systems that we make work. We may not know exactly all the details of a chemical reaction, but we know that if we heat it up, or we slow it down by cooling, or we add a bit of this and that, we can move it in a certain direction. We have some rough theoretical feel of how things are operating, and then we put a chlorine in or a bromine in, electronegativity and things like this nature, and we skew the process to the way we want it. And so vice chancellors at universities seem to think that they can do science without chemistry, and that's just ridiculous, because I think chemistry is now chemistry grounding is more important today than it ever has been. And I think that if universities cut chemistry departments, as some have done, this is infinite stupidity. They should recognize that science has changed into an extremely interlocked, cross-disciplinary subject where you can't do groundbreaking work without an understanding of how atoms stick together. So you've hit on something that's, I think, is very important. It's not that it's had its day, it's that it isn't recognized, and it's sort of a hybrid between, you know, the Tasmanian devil or whatever is a hybrid, sort of, these animals are hybrids, and they do need chemistry because it's fundamentally we do have to stick things together.